Greetings to all, welcome to the channel SimTech05. In previous video, we talked about a simple part trick that can make our assembly very easy. So with the help of the same trick, we try to make assembly of this column with some embedded members and plate and stiffeners and so on. So this may be look like very easy, but when we try to make those parts and try to make them assemble, it will be little difficult. And let me show you here in this assembly we have 115 number of instances. They were not visible in the shaded mode, but they are visible when we go in the wireframe mode. Here you can see lots of embedded member and concrete slab, base plate, stiffener and so on. So to make such assembly we have two methods. One typical method that you already know. Let me show you here. The part B, go to the shaded mode and let's open this one. Here actually I have three models. I created three models. So first model I shown that the final model, final assembly that I want. The second model is the B model, that is unarranged model. When I call those parts in the assembly, they will call likewise and you have to make them arranged. Or if you have such technique, such method, such trick that when you call the components, let me call here in the arranged model, let me double click on the instance and let's say base plate, concrete slab and those all component. When I click on those component, they will be already arranged in a predefined manner. So only you need to place this component from here to here. It will be very easy, like select these two components and move in the Z direction. Let me flip by distance of 50. Only with one click you are able to make them arrange. Similarly, you can make them arrange this component and this component. So it will be quite easy. But the question is how to generate such parts that they are already arranged for the assembly. It will really make our life very easy for simulation purpose. Because we are not a CAD designer, we are not going to concentrate much on the assembly. The final outcome that we want is simulation result. Okay. So Abaqus provide this effortless technique with part modeling itself. And let me create one more model. So how you can create? Double click on that model and you can say model 4 or you can say D, and that is the try model. Okay, click on, go to the part. So now we are in the D model and we are trying to create few parts. We are not going to follow the typical method in which we create n number of parts like part 1 plate, part 2 column, part 3 embedded member, part 4 base plate and so on. We are not going to make assembly likewise. Instead, we will create a single part and in the single part we will try to create the all components. So again, let me show you, this is the assembly. So you have to make a plan, okay, how you can create those n number of components in single part. So here you can see this is one slab, second slab. This image should be in your mind, or you can draw a rough sketch on the paper, so it will be helpful to make assembly. So we have these parts and then we have this trapezoidal support, then stiffener, base plate and so on. So as we know, these component, this side component will be pattern actually, and here also the same pattern we will use. So no need to create those parts multiple times, only one part we will create. Similarly, this trapezoidal component also going to be pattern 2 times. So we will use only one part. Similarly, this part, of course, this concrete column also pattern 2 times. But for sake of simplicity, we will design 2 concrete slab. Why? I will show you. Because we should have a clear picture actually. See, when I'm going to make a design, I should have a clear picture. Okay, these 2 concrete slab we have, not slab, column. These 2 column we have, and with respect to these 2 column, I have to make a arrangement of other components. So that's why these 2 column I will create individually. Individually means in a single part, but let me show you. Go to the part modeling. So the whole assembly I want to create in the single part. So let's say this is the part 1 and define some approximate size, then click on continue. This canvas size is important, as I also mentioned in my previous videos. This is the size of the sketch canvas, and that is the canvas actually. Sorry, that is the canvas actually. The size of this canvas. So always start with the reference axes. So just go to define first 0 point, and then second point again first 0 0, and then second point is somewhere in the vertical, and make them fix. So your assembly will be not move. Okay, here part modeling we are performing, but within the part itself we are going to make number of components. So this geometrical constraint toolbar is very important, so I'm not going to close it. Okay, now I have to create the concrete columns, and we need to provide the dimensions. This height was, for the problem that I shown, 1550, and the width from this point to this point, this width is 60.5, and the distance I am taking around 54 divided by 2. Okay. It is from the center because I want one mirror copy of this component. So just go to the mirror. If it is not available, press and hold, and here it is available. Mirror. I want to copy, select the axis, and select the component which you want to mirror. I don't want to mirror these axes. So, okay. So this is my first step, and I'm going to make them extrude with the value of 116. Yeah, okay. So it's look pretty recognizable if I create 2 column. If I create 1 column, then it will be little bit confusing. Okay. So you have to decide which is your base component, and with respect to that base component, other component will be assembled in it. Okay. So the next is I have to create one trapezoidal section. So where I have to create? If I directly create on these faces, then what will happen? The section that I will create will merge with the existing component. Okay. See, here also I created 2 components. So software able to make difference between these 2 components. Okay. Software able to understand this is the different part, this is the different part. Right now those are in the same part, but later on we can do that. So what I recommend to always create a reference plane. So here we have the second options, reference plane. Of course, those all options for the plane. The second options, and the most important point, make them independent. Means whatever geometrical modification you will do will not affect the datum plane. So let's say I want to create a trapezoidal section here. So first I have to create a plane and enter value and say direction. Okay, and distance of 50, I'm going to create a plane likewise. Similarly, I can make number of planes very quickly, and distance is 50 because I need those planes for other geometry creation. This I always recommend. Create multiple planes. Why we cannot do geometry creation on the same faces? Because if I do that, then what will happen? The new geometry will merge with the existing geometry. Okay, that's why I'm not doing. Okay, fine. Then go to the extrude options here and create geometry on the plane, not on the face of the existing solid, on this plane. Then you have to select a vertical direction. This is my vertical direction. Okay. Now I want to create the trapezoidal section. So if I want to utilize these edges, background edges, for the reference, what you can do, project edges, select these edges, and now those edges are available for you, but those are the solid edges. I mean to say, those are the line that will create geometry. So make them as construction geometry. So select this option, construction geometry, and make them in construction form, or you can say the dotted form. That will not play a role to create geometry. So okay, now I want to create the trapezoidal section. Let me define. Okay, fine. Again, go to the geometrical constraint. The first thing is this line, vertical. Second important point, I don't have midline. Let me create a center line. So this is my midline actually. From here also you can see this is the origin point 0, 0. Go to the fix, then define the symmetricity. Select the symmetric axis, then entity to make symmetry. Okay, and coincidence this with the point, and define now parameter. This value is around 165 into 2, and this height is around 50, and this value, this length is 230. Yeah, as well as the total height is also 200. So now this is my trapezoidal section created very well. Okay, parallelly, you also can create the supporter, the side supports that we seen in the previous assembly. So if you want to create, just go to create likewise. Make sure the symmetry. Why? Because it is exactly in the mid. Symmetric axis, then the lines to be symmetry, then the parameters. Let's say this is around 120, then this height is around 100, and thickness for the both is same. Okay, that's why you are able to create. Otherwise, you need to create them individually if the thickness is different. So that's all. But this distance also I want to define, and this is around 200. Fine. Okay. Define the value 10 and click on. So now you can see these are the 4 components, 2 concrete columns, 1 support and 1 trapezoidal support. So these are created in very systematic way, but see, these all are in the single component. That's only the problem. Means these all components are in the single part. That is the only problem. So let's create more parts. We will see the solution. So in the bottom, I want to define the base plate. Let's say this is my base plate. This is the center, so you can create a center line. Go to the symmetry. Here it is very easy to make them symmetric and all. But in the assembly, it is quite difficult to figure out whether those are symmetric or not. So this is my assembly. I mean to say the bottom plate of the assembly. That's all. And the thickness in the downward direction, that thickness is around 25 One more thing, I not provided the dimensions. Here it is. Let's say the dimension of the rectangle plate. It's only 300. I'm defining around 400. Okay, now it's pretty good. Yeah, fine. So let me create. Go to the planar wire. Here we have lots of options. You have to utilize the first options. Go to the plane, then you have to select the reference direction. So now go to create embedded member, and if you want to utilize these references, again go to the project edges, then make in construction line. Okay, so this distance I have to mention, that is 10. It is also 10. Similarly, this value also 10. This value also 10. So this is my first embedded member. Let me create another one. See, every member is separated. Okay, I mean to say no component is touching each other. Okay, otherwise they will make a combined component, and that will not fulfill our requirement. Similarly, here I'm going to create one wire feature, and that wire will behave like reinforcement again, embedded member again. See, here I'm not able to utilize this edges. Even I not required because this is very straightforward single line of length 1550. So I not required. So now, okay, this all part are created. Only stiffener I want and one top plate I want. So again, the top plate I want to create. So go to the extrude options, and here I can create a top plate, and this is my reference edge. But the top plate should not be overlap this one. Okay, I can define the parameters, or what I can do, let me show you. I can create somewhere here, but if you want to create exactly on the place, what I can do, I can create one more plane. Let me show you. I can create one more plane. Make sure you click on this make independent. So if you make any changes on the geometry, it will not affect the children features. Okay, so 50. Yeah, now I have one more plane here, and now I can create geometry on the second plane. So this is my top plate on which load or pressure will be applied, and if I want to utilize these edges again, make them construction line, and then I can define the distance and all. This distance may be 20, this distance may be 30, similarly distance 30, and sorry, this one, this distance is again 20. Fine. So this is my top plate of thickness maybe 20 mm. Click on OK. So this is my top plate. So assembly is almost complete. Yeah, stiffener I have to create. So how I can create a stiffener? Stiffener I can create exactly on the mid. So I need one more plane, or I can create on this plane. So I will translate from here to here. It will be not difficult. The idea is we have visualization of the whole assembly. Okay. So go to the create extrude pattern, and this is my reference axis, vertical axis, and let's create. In this way the stiffener will look like. Okay, and make sure this line is vertical, then define the parameters. So this space is around 72 and the height is around 50 or 60 and thickness is around 10. So 10 and click on OK. So now I'm ready for assembly. So let me move in the assembly, and if you directly call this part and click on OK, you are not able to move the any of the component. Like if I try to move this component, it is directly asking for the values because it's a single component. It's not an assembly right now. So to make them assembly, what I have to do in the part modeling, see this is our model, D model. Only one part I have to right click and make copy. Let's say copy here and check on these two options, separate disconnected region. That's why the separation of the part is necessary. See, no part is combining with respect to each other. I mean to say no part combining, okay, means all part are separated. So check on these two options and define any name that is not already available. Let's say beam, let's say beam, or maybe you can say component. So it will be automatically create n number of parts, those are disconnected. Just click on OK. Here we have only one part. Just click on OK. Now here we have 9 and 10th part. Okay. So rename them so it will be easy, or you can directly go with the assembly. You can directly go with the assembly. So just go to the assembly. I'm going to delete the existing part, the single part that I have, that I created previously in the assembly. Instead, I will create these 10 components from component 1 to component 9, not 10, sorry, 9 component. Now click on OK. So, as we know, this plane I was created at the distance of 50. So, very quickly you can go with these options. Okay, I not recommend to utilize these options. Only in this specific case you have to utilize, otherwise use the translate and rotate options, because the software will create the constraints between the geometry and then moving those components with respect to the constraint will be difficult. Okay. So just move this component in y direction. Let's say this is the 50. Fine. Similarly, these plates and trapezoidal support in z direction, but different opposite direction. 50. That's fine. I know the distance. Why? Because I created plane at the distance of 50. Similarly, this from here to in downward direction, I can select this edge, whatever edge you want to select. Let's say this is the direction of translation. I flip the direction and this distance is 100 because 50 plus 50 it becomes 100. Okay. So now I want to move this component at the mid. Select this component, select the translate, select the component and precisely select the midpoint. If you are not able to do, then go to the wireframe mode. Okay, then this point, not this point exactly, I want to pick this point. here. Okay. I think I made mistake. Yes, it is here. Let me check in the shaded mode. Yeah, looks perfect. Now go with the okay. So now assembly is created. Go to the pattern. What I want to pattern? I want to pattern this component in the opposite direction, not here. And this distance you must know. So let me give only one component and let me choose the direction, but in the opposite. And this distance is 116 plus its thickness, and the thickness is I think 10. So 126. Yes. Yes. So similarly, I can make copy of this component because I need the multiple support. Select the component, select the first direction as vertical direction, and the second direction because not only in this direction but also in this direction I need components. This is my second direction. Make sure you flip. Yeah, it is already in this direction. So this component is not visible because offset distance is less, 126 as we calculated for the previous component, and here in the vertical direction it is around 300. And how much component I want? I want the 4 component, not 5, 4 components. Now click on OK. So see, assembly is almost done. Only one copy of this component you want. So again, you can create new component and then make it rotate and so on likewise, or you can use the pattern component. So see, renaming is important, that's why, because we don't know which component it is. So let me find out which component it is. Center view, hide instance. So it is hided, and this instance is hided component 9. So again show it. So component 9 I have to call. Component 9, I called it. Then go with the rotate with one of the axis and 180 degree. That's fine. Then I have to translate it from where to where. From this center point. If it is not visible, then go to the wireframe mode. Again go to the shaded mode from this point to this point. So sometimes this center point is not available in your case. You can create the center points, number of points in part modeling. So that's look pretty good for me. Then the final is the embedded member, and as we know, the distance of this member is around 50. Okay, so if I directly place with the distance of 50, it will be exactly on the surface, of this column. But I don't want exactly at the surface. I want little bit more distance. And yeah, reverse the direction. It is 100 in my case actually. So here it is. Okay, so go to the top view and wireframe mode. Now you can see this is my embedded member that placed, but still this wire is not yet placed. So how you can place? Go to the choose one point, choose second point. Okay, fine. Then you must know the distance of this wire from the reference point, whether your reference point this one or this one. You must know the distance. Okay, so translate. I'm not able to select this feature properly. Why? Because this member is before the wire member. So what I can do, I can simply create a window, selection window. So multiple component will be select. Then I can deselect the remaining that I don't want. Okay. And this distance in x direction, with the direction is 5 mm actually. And again the same selection method and deselect which you don't want to move. Then y direction, or you can say in this direction, that is z actually, not y here, and the distance is 8. So this is the location. In top view you are not able to see this member, but if you want to see this member you have to first define the properties. Why? Because the y feature is not available, not visible from the top view. Okay, so let's say component 1, 2, yes. So let me create property for this member. Material, whatever material I have, I even not define the properties, parameters of the materials. So let's say beam section, because I'm interested only for visualization of the 1D component, or you can say 1D beam. Say the radius of 2 maybe. Section is created. Now assign the section. Okay. Still, if you want to see the cross-sectional area of the beam component, you have to go view part display options. In assembly, you have to go with the assembly display options, render beam profile. But there is no beam profile because the direction yet not assigned. Okay. Let's say the direction is 1, and for these two members, let's say direction is -1. Fine. Similarly for component, I think it is, yeah, component 8. Let's say assign the existing property that I created earlier. Then go to the direction, view, part display options, beam profile is 1, then why it is not visible. Okay, yes, dimension is visible, but that is very less. So go to the assembly. Now you can see this diameter is visible here. Okay, this diameter. Make sure you are in the view, assembly display options, and here this option checked on. Otherwise diameter will not visible, and if diameter is not visible you cannot visualize the place. So again the copy of this member I want, let me select this member. See, actually these members are selected and I don't want to select the other member. Let's say in x direction, I'm not even sure which one is x direction, so let me select this is x and this is z. So in x direction, with the distance of 10, I want 4 copies. I know the values, okay, I know the values. In your case, you must know the values. In the y direction, the distance of 20, I want 4 copies. Oh, I have to define the reverse direction. So let me delete those members. Those members are grouped actually. Just go for Control Z. So member will be ungrouped, and component 8. Okay, this all component I want to delete. Yes, this also I want to delete. Only this component I want. Let me go in the direction. Again the same process, X, and number of pattern maybe means number of copies, maybe 4 with distance of 10. Here with distance of 20, number of copies are 5. But before press OK, you have to make sure what is the direction. See, the direction is something else, and the second direction you have to choose this one. So make it reverse. Now go to the, see, now they are at the position. Go to the OK, and now things look pretty good. Again, yeah, here it is. So similar process you have to follow here, or what you can do, you can directly copy them all here, or you can say you can pattern them all here. So before making pattern of these component, let me create pattern of this cross-sectional embedded member. So let me define, select the component, deselect the component that we don't want. Okay, only this component I want. Choose the direction. This is the direction. Obviously reverse one. Go to the front view, and now you can see the pattern. So in other direction only one pattern, and the distance of 50, and how much copies I want, I think 20, no, not 20, I not remember. So go to create manually. Yes, here up to here. So how much copies? 30. Yeah, 30 copies we have. These members coming outside, so I have to make them up, I think with distance of 50. Yes. Fine. And now I will make pattern of these all. So how to make, select the all component. May worry that we don't want to select the all components. Yes, that's fine. Then deselect. Okay, deselection is easy. Then deselect likewise. Only these inside embedded member I want to copy. So I selected the all member which come in the window, then I deselected. Okay, so now done, and I want this X direction. In direction 2 I don't want any copy. In X direction I want reverse direction, not 200. Let me measure. Just go to the query icon, then distance, and from this point, or I can say this midpoint to midpoint, that distance in X direction is 114.5. That's fine. 114.5. Okay. Now click on OK. Now go to the dismiss. So in this way you are able to create the whole assembly. Of course, embedded member will always problematic for assembly purpose because they need lots of concentration, position, and so on. But you can see even this method is way better than the typical method. like we have to call each and every part individually and then make them position. So that's all for today's video. So I think in basic playlist, Abaqus Basic for Beginners playlist, I covered the massing, part modeling, and assembly. Here we have few more features. That one important feature is merge instance. That is nothing but Boolean operation. Is very important. I will create a separate video for this with the example, and that is really very helpful. Okay. So apart from this, part modeling and assembly is finished, and we will start with the property assignment, then step. Thank you.